All right, moving into Unit 2, Lesson 2, we're going to look at how to perform operations on polynomials, which are just many-term expressions. So remember things like coefficient, degree, number of terms. We're going to look at how to then add, subtract, and multiply those. So a term can be a single number or a product of a number and one or more variables raised to whole number exponents. And we're emphasizing that because there are other types of exponents that we can have. We will not be dealing with those in this unit, or in this lesson. So you could have negative exponents. You can also have rational or fractional exponents. If we get negative exponents, we are going to make them positive, and we're just not going to deal with fractional exponents at this time. We'll do that later on. So here's some examples of polynomials. So again, you can have a single number like 3 or 7 or x. And then you can have a two-term polynomial. So this is 1, 2 terms. Or you could have a 3-term polynomial. These don't have like terms, so this is as condensed as these particular polynomials can get. All right, so vocabulary: coefficient is the number in front of each variable. And so, for example, in this last problem here, the coefficients are 4, 7, and, just 4 and 7. And then 6 is not a coefficient, it's what we call a constant. And so this is a constant. It's not affected by the value of a variable. So 3 in that first one would also be a constant. A polynomial can be a single term, or it can be the sum of a finite number of terms. All right, now each of those has a different special name, but they all fall under that umbrella of polynomial, so subsets, if you will. A monomial, mono, meaning one, is a polynomial with a single term. If you think about the prefix for 2 in math class, you should be able to come up with one, but the example like 3 up above would be a monomial, but so would 2x squared y. This is still a monomial. A binomial means 2, so it's a polynomial with 2 terms. Now it's important to note what separates a term. A binomial would be like the second example above, which was 2x plus 5, because it has 2 terms, so it's a binomial. Once again, it's anything that is separated, a term is separated by add or subtract. Right. And then the last one we're going to name is a trinomial, which just means having 3 terms. As you can see, these are kind of color-coded here. So 4x, it's not a negative, it's glitching. 4x squared plus 7x plus 6 is a trinomial because it's got 3 terms in it. All right, the value in front of the variable of the highest degree. All right, we're going to write all the polynomials in descending order by exponent, and the value in front of the highest degree exponent is what we call your lead coefficient. And so for this polynomial, for example, you can see our exponents are in order. We have 3, 2, 1, and then nothing, so technically 0 if you want to be technical there. They go in descending order. So your lead coefficient is 2. Okay, the number in the very front once you have it in order. The degree of a polynomial is the largest exponent. So you're just going to look at what is that largest exponent. That is going to be the degree of your polynomial. All right. So for example, we're going to write this one in what's called standard form. And that is just putting them in order from least to, or from greatest to least exponent. So we have negative 5x cubed plus 7x squared plus 3x plus 6. And so the degree of your polynomial is this highest exponent here. And your lead coefficient of this polynomial is this front number here. And it's just the number, it's not the x. And then this one, what else we can tell about it is that it has 1, 2, 3, 4 terms. We don't have a special name for that, so it's just a polynomial. Okay. All right, so moving forward, we're going to talk about just a quick reminder of what function notation is. Instead of saying y equals, we're saying p of x or f of x or g of x. The function of x is what? And so when you are evaluating something, you're plugging in a value. And in this case, x equals -1. So a function of -1. So we're going to just substitute in here. P of -1 equals -1 squared minus -1 minus 2. All right, well, -1 squared is +1, minus negative is +1, minus 2. Those are all going to add together and cancel out. P of -1 equals 0. Okay, using your rules of exponents and what you may or may not remember about Algebra 2, I want you to go ahead and try this one. Okay, so I just kind of flipped it to horizontal. You don't have to, but I just wanted you to see that it could be written either way. What you do have to do is, whether you're doing it vertically or horizontally, you need to make sure that if you are subtracting, that sign goes through to everything, so that you're taking -3x squared minus x squared. And you're taking 5x and you're subtracting -5x. Okay, and you're taking -2 and you're subtracting -6. And so just so that you can see that visually, sometimes it helps to distribute it. So then we can just combine like terms. Remember our exponent rules. These are going to stay the same, only the coefficients will change. So -4x squared. This changes to plus, so we get plus 10x. This again changes to plus, so we get plus 4. All right, so now we're looking at distributing. Remember, you can distribute exponents if there's no addition or subtraction. When we distribute whole terms, we need to keep in mind our exponent rules. So this is x squared times x. All right, so we have x to the third. And then we have x squared times -4. So we have -4x squared. All right, then we have -3x times x, so we get -3x squared. And -3x times 4 is +12x. And then we do the same here. We distribute our 2, so we get positive 2x, and distribute here to minus 8. The last step with these, so double check you did all your signs right. Remember that we're adding our exponents when we multiply like bases. Now we just want to combine like terms. And the way that I multiplied it, my like terms are already lined up. Otherwise, just draw yourself a line or regroup, whichever one works for you. So we get x cubed minus 7x squared plus 14x minus 8 as our final answer. All right. Another thing I want to note real quick before I move on is that you can always flip this around and do x minus 4 times x squared minus 3x plus 2. It means the exact same thing. Another option, even still, is to take x squared minus 3x plus 2 and to stack x minus 4 and to multiply like you did when you were younger with multi-digit numbers. Okay. All right, when you have this like this, do not distribute that square. So don't do 2m minus 7 squared and distribute this. All right, this will not be right. Because what this squared means is that we are taking 2m minus 7 times 2m minus 7. All right, so we're multiplying it times itself. So we're going to distribute that 2m through, so we get 4m squared minus 14m. And we're going to distribute the 7 through, so we get minus 14m plus 49. And multiplying by itself results in the same thing every single time. We're going to have that first term squared, all right? We're going to have double this middle term, and then we're going to have the last term, or the second term, squared. All right. So that's what we call a perfect square trinomial, and it will, again, always form that same pattern. So if you have a plus b squared, that will always equal a squared, that first term squared, plus 2ab plus b squared. If you have a minus b squared, quantity squared, it will be the same thing, only that second sign will flip. So a squared minus 2ab plus b squared. All right. These are generalized formulas. You don't have to memorize those, but they do come in handy, especially when we start factoring what to do with that. All right. This also creates a pattern. Go ahead and try that. All right, so this is what we call a difference of two squares, and what happens with those is those middle two terms will always cancel out. Keep in mind here that when we multiply like bases, we add the exponents, so that's where the 6 and the 2 came from. When we add or subtract like bases, they have to be the exact same bases with the exact same exponents. All right, combining your operations, you're going to follow order of operations here to solve this out. Okay, so the first thing that we want to do is get rid of our parentheses. Well, in order to get rid of our parentheses, we have to first get rid of our exponent. And so we're going to do 3x minus 2 times 3x minus 2. Well, that's a perfect square trinomial. So if you follow your pattern, you have the first term squared minus, because we're subtracting, double the product. So 3 times 2 is 6 times 2 is 12 plus the second term squared. This is still in parentheses because this 4 needs to come down. And this whole thing needs to come down. Okay. The next thing I do after that is actually get rid of my parentheses. I'm going to distribute here and here. So I have 3x minus 3 minus 36x squared plus 48y to the fourth minus 16. That's a plus sign, sorry. That's not a fourth. Minus 16. And then we are just going to combine our like terms. So I'm going to write this in standard form. My highest exponent first, so negative 36x squared. I have an x here and an x here, so plus 51x. And then I have a constant here and a constant down here. They're both negative, so negative 19. All right. You can always FOIL this out the long way. If you can't get something to work. All right, last one, we're going to disregard the homework at the bottom of some of these. We're going to use what's called U substitution. Okay, so up here, we still have to watch for PEMDAS. That doesn't go away. And because that's true down here as well, it's often easier to just kind of think of something as one big term, excuse me. So like, for example, think of this as a plus 3 times a minus 3. Well, we know this pattern. This is difference of squares. This is a squared minus b squared is how this will factor out. All right. And if you know that pattern and you know that this always factors as a plus b and a minus b, then this is a huge help when we factor. Okay, so the more patterns you memorize, the better off you'll be. Well, here, the a term, we can see here, is equal to the x plus y, right? And the b term, so to speak, is our 3. It's our second term. And so that being said, we can take this big shortcut and say, okay, well, we're just going to end up with a squared minus b squared. So that is x plus y squared, that's our a squared, minus 3 squared, that's our b squared. Now we can simplify. So this becomes a perfect square trinomial. So we have x plus y times x plus y, which means we have x squared plus xy, if I distribute here, plus xy plus y squared minus, do that in a different color, minus 9, which comes from here. All right, combine like terms and then we're done. We have x squared plus 2xy, remember your exponent rules, plus y squared minus 9. And that is our final answer. Okay, so watch for order of operations, learn some of your factoring patterns, and have a great day.